Hello, this is Natalie Tarry going through a predicted paper for IGCSE Foundation Level, Paper 2, Summer 2023. Now, this paper was created by somebody else. It wasn't me. I'll be honest, I cannot remember who it was that created the document, so I will put the credits on later on. So if I share this onto YouTube, on public view, I will have put it in the comments. And if I haven't, give me a little nudge and I will do. Okay, so I didn't create it. I have a student who is doing the IGCSE paper next Wednesday. So I'm recording this on Monday, the 1st of June, the day of the calendar swap over. And I have Simon Le Bon on my calendar now. I've moved it. It used to be in front of me. I've now got the lyrics to Save a Prayer. Anyway, so what I'm going to do now is I'm going to go into a document called OneNote, and I have got, I'm just going to put it up in here. Now I have my trusty pen. I have my tablet here. Now I have discovered something that's going to make my life so much easier. If you're coming to the end of your time with me as a student, you're not going to see this. However, you may do one day. Okay, so all I'm going to do now is I'm just going to pick out the section that I need. Here we go. This is the one. Okay, so we are talking IGCSE Maths, Summer Paper 2, Practice Makes Perfect. So what this document does, it's telling you the topics that are likely to come up. Now, what we know is we know the syllabus. We know what's due to be, what is examined for students to show they know how to do, or what they can remember and what they can recall. One thing I will say at this point, and I will look straight to the camera, is this is a reflection of what you can do, what you can remember, and what you can apply on that one day. It is not a reflection of how well you can do maths, or how you can perform in exams, or how you are as a person. It's just a reflection of how you're able to do on that day with those problems in front of you. Okay, now I will be going through a few of these. I'm not going to duplicate work, and I will just go through a few things, what I would do, how to start certain questions. Okay, because I know more than anyone, one of the big things that's like a barrier is I don't know how to start. I don't know what method is required. So, but that's okay. I will sit here and I can imagine there's been lots and lots of hours of saying, I just don't know what to do. It can't be that easy, surely. And I'm like, yes, it is. But you need somebody to talk you through these skills. Remember, you didn't learn to walk straight away the minute you were born, did you? If you've learned how to drive, those skills, now if you're somebody obviously watching this as you are a 16-year-old, obviously you won't have gone through that, but your parents would relate to this, brothers, sisters, whoever. When you first learn how to drive, everything's all a bit clunky. You're like, oh, I need to change gear. Oh, now I need to look in the mirror. Now I need to do this. And that is probably how problem solving might be to you initially. Then you get to a point where you're like, I just do it without even thinking about it. I can often, I genuinely have no idea what I'm doing when I'm driving. I just drive, I just do it. So what I'm going to do here is I'm going to go over some key skills. I am also going to go over those skills which are not mathematical, but problem solving skills. The scaffolding, the thing that says, what's in front of me? What can I do? What rules do I know? What can I work out? I will repeat those time and time and time again with every single student to the point that they're doing it themselves. So, angle problems, basic rules. Okay, so it says isosceles triangle. Okay, what do I know about an isosceles triangle? What does that mean? I can work out. Before I've gone any further with the question. Angle ACD. So angle ACD. So basically it says go from, I can do this here, go from, where is A? It's up here. So A down to C. I'm trying to do this right there, down to C. down to D. It's that one there. Okay, at which point I now do undo. Okay, do that in a colour. I'll do it with a pen, and I'm just going to get it on the right thickness. Here we go. And I can actually draw lines. I'm very new at this with OneNote. I have used OneNote before, but basically this is the angle that we are working out here. So what I normally do is get my highlighter pen and I'll be like, that's the one. Okay. So it says BCD is a straight line. Okay. Work out the size of angle X. Problem solving skills then. Isosceles triangle. What do I know about that? Isosceles triangle, two sides of the same length. And that's what those two dots are there for. Yeah. So those are the sides of that triangle that are the same length. We also know with isosceles triangle that that angle there is the same as that angle. So I would literally write on there and I would put on X. Okay, I'm just doing that with my mouse. Okay. So, okay, I've got a triangle. Angles. I know angles in a triangle add up to 180 degrees. Okay, so I'd probably write that down. And then I've also got a straight line. Angles on a straight line add up to 180. Now, in my arm, I'm going to show you something. Our trusty little protractor. This will come in handy for you to remember this rule, because when we are looking at angles on a straight line, basically, imagine this at the bottom. I know you probably can't see it as clearly. Put something behind it. That line at the bottom is effectively your straight line. So it goes from like all the way around to the other side. Now I'm going to relate that to here. So I am literally going to do it. I'm going to do it in red. And I'm going to move literally so we know that angle and that angle add up to 180. Okay. So you think it's like the semicircle. You see how I drew it, how I drew it as one. So therefore, that angle there, so I can say the angle, so we can say BCA is equal to 180. I've ended it right at the end of my pad. Okay, so it's equal to 180, take away 62. No, that's not the angle we've been asked to find. So I'm just going to put the degree thing on there. Now, calculator paper, make use of your calculator. So before you even pick your calculator up, good practice, what are you going to do? How do you know that's the case? Angles on a straight line. So I'm just going to do 180, take away 62, 118. I think that's right. Just double check it again, because I know it's so easy to make a mistake. I'm just going to put this on here. So 118 degrees. Now, here's another little tip for you. Going over here, you've got 118 degrees. So I'm actually going to write that on. I always remember an angle is basically the rotation of one line from another line. Yeah, about a point. And if you go all the way round, you end up with 360 degrees. Okay, so we have got 118. Angles, we've talked all year on, didn't we? Angles on a straight line. Sorry, angles in a triangle add to 180. So I can do 180, take away that, gives me 62. And then these angles are the same, aren't they? Because I picked up this rule at the beginning. So there will be things in your question that are going to help you later on. So if you have that little brain dump of these facts, it will help you. Okay. Now, some questions ask you to give a reason. So just be careful, make sure you know your rules, like corresponding angles, the ones that show like an F side of a letter F. Get my words out there. Okay, here's another similar one. Notice this one, it doesn't mention isosceles, but it does say that SQ is equal to SR. So SQ, SR. So straight away we can put in there and we can say that that angle is, because it's the same as the other side, because these two sides are the same. So the angle they make with the base is the same. And then it says work out the size of angle marked X. So that one there. So that will be 130 degrees. Why? Because isosceles triangle, these two angles are the same. And again, you've got, and I'm going to put this in a different color. Remember, can you make a semicircle with those two angles? Yes, we can. So therefore they add to 180. Okay. Now, I don't think I've covered this one. So here we've got angles. I'm keeping an eye out because I've asked the student I'm actually recording this for. I've asked if she wants any help on specific topics. So one little tip. Well, lots of tips. When you get your exam paper and you've got a question like this with lines and angles on it, remember you can rotate your paper. Okay. Now I know that probably sounds like, what? Of course I can. I'm super glued to the table, is it, Natalie? But how many times have you thought, right, if I just turn it around slightly, do I get a different view? See if you can keep noticing these little nuggets that I keep giving you of little tips. So we have got parallel angle, we've got parallel sides. With that, then comes rules that you can use. Okay, so as soon as you see or you have to deduce that lines are parallel, okay, there's those corresponding angles, there's alternate angles that are equal, there's interior angles, there's vertically opposite angles when you've got an X shape. So look out for things like that. So I'm looking at that and I can see that and that's alternate, because if you look, we've got a little Z shape there. I know I did that with the pad thing there. So they're alternate angles. In fact, I can do a better job than that. So is there an insert line? Insert line, there we go. I'm still learning with this. So I can do to there. I can do to there. Oops. I didn't mean to move that. There we go. And then we can do insert line down there. Right now. Okay. And then you can stick the other one in there. Off there. I didn't mean to do it all like that. Roughly, you can see. So you've got alternate angles. P, Q. Now, Q's not near anywhere, is it? However, you have a look. I'm just going to zoom this in a little bit here. Another little tip I talk about is draw a little diagram of part of the big picture. Okay, so here really what we've got is we've got a line that goes, I'm just going to pop this in here. So we've got a line that goes like that. You've got another line that's going across, and then you've got another line going across there. Yeah, those are parallel. You know that angle, oops, oops, I didn't mean to do that. There we go. Let's go back onto pen. So I know that, oops, moved out the way. There we go. Okay, so I know that that one is 50. So therefore, that angle there is 50 because it's vertically opposite the X shape. I know that that angle there will be 130 because it's an interior angle. These two lines are parallel, remember, so these rules apply. And therefore, I can then work out this angle, which is 50 degrees. Now, here's a question. Did I have to work out that one that's 130? Not necessarily, because once I found that angle there, which is 50, I'm just doing this with my actual mouse. Sometimes I use my pen. Sometimes I use my finger on the trackpad. Sometimes I use a mouse. And that one there is corresponding. It's in the same place underneath the parallel line. Okay. Right. I am going to move on from angles and stuff. Let's see what else we've got going on here. Again, similar things. Equilateral triangle. Equilateral triangle. What do I know about that? Angles all the same. All sides are the same length. So again, I can start putting on there, okay, I know that's 60, I know that's 60, I know that's 60. So I can pop those on the diagram. And then I'd literally go through and say, well, actually, what's that angle now? If that's 60, I've got that nice semicircle shape there. So that must be 120 degrees. Again, just double check my mental arithmetic. So then we've got that 60. That's 90. So it's like a little jigsaw puzzle, really. So if that's 90, what do we know about that angle there? That's 90. What do I know about that angle there? Well, I've got, this is 90. That's 90. This little bit here is 60, isn't it? Because it's part of the isosceles triangle, equilateral triangle. So therefore, this bit there is 90 take away. I'm just doing this with a pad. 90 take away 60. It's 30 degrees. So if that's 30, then you've got that one. Well, 120 plus 30 is 150. So therefore, that one is 30 degrees too. This is where I just have to double check with my calculator. Because I am quite tired. I can make, my mental arithmetic sometimes takes a while to kind of do. I always check. Doesn't mean I can't do maths, just means my brain needs to be a bit more awake to make sure I don't make silly mistakes. So what kind of triangle is CEB then? Isosceles, isn't it? What we have to do in maths is get used to looking at a problem and seeing what we can deduce from it. It's reasoning. What must that be? If that says that, what does that mean? What else can I work out? Have these as a script. If anyone is under any illusion about GCSE and how problem solving is a big part of it, it really, really is. Yes, there are lots of questions in there that are more just like factual. What's 6 times 7? What's the area of that square? These are direct skills that you know what to do. You've learned the skills. Might have to close the window in a minute. Okay, so here we're talking about finding the area of a shape. Finding the area of a shape. So what do we know about it? So the area is, it's a space. Yeah, we talk about it when we're painting a wall, looking at how many, it's almost like how many square units is really the official term of area, how many square units there are. So talks about a centimetre grid. So that means each one of these is a centimetre long. So if that's 1 centimetre by 1 centimetre, this one of these grids is one of these little squares is going to be 1 centimetre squared. So I've got somebody across the road is having like their front driveway done and stuff, so it's a bit noise. So if that's 1 centimetre squared, find 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 centimetres squared. Centimetre grid comes up now and again, just keep your eye out for it. Perimeter is as if you were going to walk around that shape all the way. So you're going to go 1 there, so that's 1 centimetre, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, now obviously I've just done that on my trackpad on my laptop, but yeah, you're just counting along that distance. So if you imagine you were physically walking, I did this with a class and we called it perimeter. So he was a perimeter. He used to like walk around his bedroom. He used to sit at one end of the bedroom and he could walk all the way around the outside and stopped. Then he did it again. And I used to physically do this around the classroom, around a desk and stuff. Anyway, so perimeter is the distance around the outside of a shape. The area is the amount of squared units inside. Just double check your unit. So if it's in centimeters, your area will be centimeters squared. Lines of symmetry. Now, I liken this to when you're in school and you used to like, obviously I'm going to do that again. I can do a better job than that. So when I'm doing this and I'm talking about it, I know I'm not on an art course. So there we go. So that is a line of symmetry. What that means is that if you were to take your piece of paper and fold it along that line, everything would match on both sides. Okay. I always liken it to that it's like a reflection. It's like a what you learn. Remember when you were at school and you used to do one side as a butterfly, you put in the middle, and then you suddenly have a butterfly. Oh, excuse me. Okay, so what else have we got here? Now, rotational symmetry. Now, I haven't done all the lines there. This is again where you can get your piece of paper, turn it around, and just say, well, what does it look? When does it look the same? Now, some might say, well, actually, if I could put a line down there. But if you turn your paper round, you will see that this distance here is not the same distance as there. So we'd kind of be a bit stuck. So we couldn't really do that. So just have a play around, putting your lines and stuff. Rotational symmetry is literally how many times you turn around the piece of paper, this shape, and it looks exactly the same. So we can see here that there's something in that corner and something in that corner. So it doesn't matter, and I'm just going to pop this in now. I'm going to put, actually, no, I didn't want to do that one. I wanted to do the top, so I wanted text to draw. Oops, where are we? I'm just going to do, we're in draw. I've got lots of little menus coming up, so I'm going to put here is I'm going to say this is the top. Okay. So if I were to then rotate that around, so it's at the bottom, and we know it's got rotational symmetry of order 4. So that means you can turn that round once, twice, 3 times, back to the start, and it looks the same each time. So we know we've got to have 2 things on the bottom here shaded in. So I'm going to have to do that. Okay. I also know that there's one here. There's one shaded shape here. So that when this is at the bottom, I need to have one there. Yeah. Now, have I got everything now? Is that going to be, do I need to put any other shapes in? Well, when I turn this round slightly, I don't know if I can rotate it, I also need, I'm looking at it, I think I need one in there, because it's got to be one up diagonally from the right. So when I rotate that, that needs to be shaded in, and that needs to be shaded in. 1, 2, 3, 4, 5. There we go. And again, you're at an advantage when you're doing this with your paper, because you can just turn it around. Put top at one end of it, so if that helps. Now, what I'm going to do now is I'm just going to move over a little bit now. So area. I know the person I'm recording this for, sometimes it's about kind of working out what shapes are there. Quite often we can have like find the shaded area. Now, is this a standard shape that you know? Well, it's got 1, 2, 3, 4, 5. So it's a pentagon. It's definitely a pentagon. However, it's not a regular pentagon. So it's a 5-sided shape. I don't know what shape it is, but I have got this. I've got a way that I could, if I put a line through there, I've got a rectangle. So I'm just going to write on here 8. Oops, it's much easier if I use this. 8 times 11. And then I've got this here, haven't I? Now, have I got all the dimensions for this triangle? I'm just going to put the triangle on the side. I do sometimes kind of just do little sub-drawings. Okay, so the length across there, well, I've got 7 to there. And from there to there, it's 4. So I know that that one there, it's 4 centimetres there. And what about its height? Because for finding the height of a triangle, it has to be the perpendicular height. Perpendicular, what does that mean? Makes a right angle with the base. So we have got, so that'll be that side there. And well, we've got 8 over here. We've got a 14 over there. 14 take away 8 is 6. So, and again, calculator, just double check. You know, I've noticed as I got a bit older, I think, oh yeah, it's that answer. And it's like, oh no, I mean one thing, but I say something completely different. So but I notice, I pick up on it because I'm very, very aware of what I'm saying and what I'm doing. So there we go. So what we've got here is, and let's just see what it's asking for. So it says 7. Have these all got the answers in them? Oh no, it's page. It's that looks a bit deceiving, doesn't it? It says 7 centimeters. It's not 7 centimeters. That's page 7. It's on the thing I've imported it into. Okay, so basically we've got area of rectangle would be 88 centimeters squared. Area of a triangle is half base times height. So it's 4, and I'll just pop that down. I'm just looking to see if I can get a smaller nib. 0.25. If there's a smaller pen I can use, because it's quite a big thickness, I think, on this. So basically it's a half times the base, which is 4, times the height, perpendicular height, which is 6. And a little tip here again, calculator, stick it in the calculator. If not, half times 4. Half of 4. So split 4 into 2. So that's 2 times 6, which is 12. And I'm just going to put the steps in there. Equals 12. And you'd have the equal sign in there. Okay. Add them together. So make sure you show you're working out as well. So area of shape, I would call it. Sometimes I do, well, I'm just going to put this back in there. Sometimes I say, okay, shape A and shape B. Show your formula, show your rule, put your numbers in, again, write it down. Use your calculator to check, and then obviously add the two together. Okay. Now, I am an examiner. I have been trained to be an examiner for a QA exam board. So that means that I get to mark over 400 foundation level papers in July. I can't wait. I genuinely, it's something I've wanted to do for a while, and I've just not managed to get in simply because they've not been vacancies. So, you know, a lot of people, you know, are examiners and they tend to stick with it. So last year I didn't get a spot, but I was in the pool. But so I ended up doing like general marking, you know, no skill of a mathematician needed per se. So this time a vacancy came up and they've offered it me, so I'm doing that. And as a bit of a tip for you, and this isn't me giving you inside information, we want to give students marks. We want to see how you work things out, because maths is not just about the answers. Maths is about a wide range of things. Your concept of shape. Do you know what shapes are? Do you know what area? Do you know what angles are? Do you know what the rules are that relate to them? And then how you can apply that to a real problem. Can you look at a problem and say, what do I know? What do I know about that? What does that allow me to work out? Yep. Is there anything on the diagram that I can write on? So I'm just looking at this now. Obviously, where are we now? Page 8 into an 87-page document. So I'm going to skip through some of these. But I think shapes are quite interesting because it says work out the area of the shape, and this is 4 marks. I'm just going to tell you now, as I'm doing this, I haven't seen these before. I think there's probably about 2 questions I picked out in a lesson. I am seeing these for the first time myself. So as I'm working through it, sometimes I go, actually, no, this would work better. So you're seeing me solve problems. Now, I'm looking here and it says it's got 1 line of symmetry. Now, that line of symmetry, let's use a line. Insert a line. It's got 1 line of symmetry. So that tells me that that's the only place that line of symmetry can go, really. So therefore, let me go back onto draw. Okay, so I know that that side is the same as that because the fact that there's only 1 line of symmetry, so they have to be the same length. What shapes have I got here? Well, I know that is okay. So we don't know, that's not closed shape, so it's like an arrowhead, isn't it? Now, what have I got here? I've kind of got a rectangle. This is what I'm looking at the minute. I've got a rectangle of 12 by 15. This is my first view. Okay. I've got a triangle here, which is 12 by 4. And again, you see how I'm kind of thinking about this problem here, 4, which is perpendicular height. I've also got a triangle here, which is, oops, I'm doing this literally with the trackpad, where that distance across the bottom there is 12 and the height is 10. Yeah? So I know I can work out the area of a triangle, half base times height. So that'd be a half. I'm going to just get it on the pad so it's actually on the page. So we've got a half times, and I'm just going to write that formula down, a half times by 10 times by 12. So 120 divided by 2 is, I'm just write this on the edge there, 120 divided by 2 is 60. So that's 60 centimetres squared. I know the area of this. This is a triangle again. I've got the perpendicular height. I've got the base, so I can work that bit out. So that's half, again, half times 12, which is 6, times 4, which is 24 centimetres squared. Again, please show you're working out. I'm just doing this to talk through this quickly. And then I've got an area, I've got a shape here of 9. So 12 times 15, don't remember it off the top of my head. So 180. It was just as I was doing it, I was like, is it 180? And I'm just going to do, again, its units. Okay, so I've seen 3 shapes. I know how to find the area. Let's pull it together then. So what have we got? We've got this rectangle. So we got the shape, and this is how I'd kind of write it down. So I would say the area of shape, not the best writing. Yeah. Area of shape is going all over the place. Is equal to the 180 rectangle plus the triangle on the top, the little spike thing, which was 60. But then I've had this little chunk, haven't I, taken out? So it's like, okay, I need to take that away. So that's taken away 24. Okay, so literally I've shown what I need to do. I'm now going to use the calculator because that's exactly what it's there for. So 180 plus 60 equals minus 24 equals 216. So that is 216. Now, what I will say is, I would give you 100% confidence in my ability in terms of maths knowledge, in terms of my motivation skills, in terms of lots of other things. Another little reminder that to be on your best, you need to be fully hydrated, foods, eating well, having a good night's sleep. So when you're tired and you're not concentrating or you're doing things quickly, just another reminder, it is possible to make an error. Okay, I'm trying to do this slowly so that I am talking through it, seeing these things for the first time, and I'm not making any silly avoidable errors. So I'm going to take away the area of the triangle. So that's 2 times 24 equals plus the area of the triangle at the top, which is 12 times 10 divided by 2, 120, 60. So 260 centimetres squared. Okay. I have not mentioned this little beauty yet, have I? That means you can sit there with your ruler and you can measure those lines. And you might think, well, when I measure that line, it comes out as 5 centimetres. So that means that this is 3 times bigger and I need to, it's not accurately drawn, okay? It's just a sketch. I say a sketch. It's an informative, it's like a pictogram really. It gives you information about something. Okay, so I am going to, let's have a look. I want one of them like these. There's another one. I'm going to come back to that one in a minute. Here's another one where you have got a problem. You've got triangle, haven't you? You've got a triangle there. Well, can I work out the measurements? Shapes like this, get your pencil, draw a line and sort of think, well, I've got a triangle and I've got a rectangle. Can I work out all the measurements there? If I haven't been given them, can I work them out? Now, if that's 10 centimetres for that distance there, that's 4 up to there. So therefore, the rest of that must be 6. So you can work out that. That's 16. That's 9. So therefore, that bit there is 16 take away 9, which is 7. So that's 7. That bit there is 6. You can work out the rest. All right. Now, this one. I love these questions. I love good old-fashioned little problems, because you've got to, this stuff you've got to work out. Yeah, you've got to look at it and say, what can I do? What do I know about what's in front of me? So we are given a rectangle PQRS. Right, let's just familiarize myself with the diagram. So PQRS. The rectangle, what does that tell me? All 4 angles of a right angle. Okay, if that's not drawn on the diagram, pop it on, because sometimes having those visuals things can make a huge difference to a lot of people. So just pop them on there. Okay, right, so PQ is 14. Is that on the diagram? Yep. QR is 9. Yep. A lies on PS. It's on there. PA is 5. Do we know what that is? That's 5. That must be 4. So again, I'm just sort of deducing what other things are, putting them on. The point B lies on SR. So that BR equals 8. So the length of B2R is 8 centimeters. So therefore, well, that's parallel to that because it's a rectangle. So therefore, these lengths are the same. So therefore, that is 14. Take away 8, which is 6 centimeters. Okay. So I find out the area of PAQB. That's an interesting one, isn't it? Because I kind of need, well, if it's a triangle, I need my base. I need my perpendicular height. And then divided by 2. If it was a higher level question, maybe I could use the half AB sine C rule. But there's no angles. I don't know what the angles are. Okay. Right. I am not going to get stuck into a doom and gloom, but I don't know that and I don't do that. So quickly switch it around to what do I know? What can I work out? Now, I've got some right angle triangles here, haven't I? So if I've got right angle triangles, I've effectively got 2 sides that meet at a right angle, yeah? One would be the base, one would be the height. So therefore, I can work out the area of these triangles, can't I? So that one there, I'm just going to call that one A. I'm just going to write them on, actually. Oops. I used my normal mouse to get me in the position. And then I'm just going to put that there. So it was a bit big there, wasn't it? And that one there is C. And then I'm going to say, well, actually, what's the area of the whole rectangle, the whole shape? How do I do that? Well, I've got 14 times 9. So I'm going to do area of rectangle. I'm just going to put that is equal to 14 times 9. I have to be really careful with this pad. If you watched any of my videos before, it's almost like it catches, because I'm left-handed, it catches the end of what I'm doing. So 14 times 9 equals 126. So I'm just going to put that in there. So that's the area of the whole one. So 126 centimeters squared. How do I know that? It's got centimeters here. Okay. Now, some questions actually give you the units. Yeah, it's telling you it's the units, so don't worry about it too much. When I was in school, which is over 35 years ago, then that sounds scary, doesn't it? But we were drummed in. It was like, remember your units? Is it pigs? Is it sheep? Is it cars? I never forget these things. Right then, so I don't know what this is. Maybe I could use Pythagoras to use find a right angle triangle. I could find the length of that, find the length of that and the length of that. But then I'm like, I don't know what's a right angle. I could measure that, but I can't because it's telling me it's not accurately drawn. So what I'm going to do is I'm going to focus on the stuff I can do. So I know the area of this triangle. So it's 8 times 9, 72. Divided by 2, 36. So I'm just going to write this on there. So that's 36 centimeters squared. I'm leaving the units off for now. Okay, 4 times 6, half of that is 12. Half of this, so we've got 14 times 5, 50, 60, 70, divided by 2, 35. And again, all of those units are centimeters squared. So I've got this big shape here. And I know it's 126. But I'm going to start cutting away at it. I'm going to take that bit away, which is 36, which leaves me with 90. Use this on a calculator. So I've got 126 is the area of the whole thing. I'm taking away the area of B, which is 36. What else am I taking away to leave that other triangle? Taking away that one there, aren't I? What's the area of that? That's 12. And what else have I got? I've got that area there. Now, obviously, ignore, I've got to the end of my pad now. I'm a lot better on this than I used to. So again, this bit is replicating of that bit there, okay? So this was 35. So what we're doing is we're taking away, let's bring this over here, this, all that bit there, all of that bit, and then all of that bit. And what are we left with? The area of the triangle in the middle. So you can carry on working that one out, and you should have an answer of, I'm just going to do that again, 14 times 9. Take away 4 9s is 36. Take away 2 6s is 12. Take away 5 times 7 is 35. So I get an answer of 43. 43, so I'm just double checked. Almost 36 minus 12 minus 35 equals 43. So there you go. So questions like this in the area, look at what you can work out. Sometimes it's like you work a big shape out and then you work out the little shape in the middle and take them away. Because sometimes you have questions like, I'm just going to scroll down here a little bit. I've got a bit of space here. So sometimes you have shapes like that. Don't you kind of have, you might have a square, a little bit, that is a square, imagine it. And then you might have something like this. And you've got to find the area of the shaded bit, okay? What I do if I'm sat with somebody and they're trying to work out what to do, I'm like, well, imagine you needed just the shaded area from a piece of paper. You need that shaded area, but you've been given a sheet of paper like that. How do I get it out? I'm like, well, I cut it out. Okay, good. But how can you do that mathematically if I'm cutting it out? What math skill is the same as cutting something out? Okay. I'm looking now, I'm thinking, I'll make sure I did record. Please tell me I did record because I've been doing this for a while now. Yes, I am. That's all right then. Right, I am going to skip a little bit on here. So here we've got, again, shapes. Square, size 10. So I'm looking at that straight away and I'm looking, well, that's going to be 7 there. If that's 12 centimeters, are we given any other bits of information? We've got B as 3. We know that what's a square? A, B, C, D is a square. A, B, C, D is a square. We know that E is a point on AB. The area of that is 12 centimeters squared. Well, actually, this distance here, I know that, don't I? Because it's 3. If the area of this is 12, how was that worked out? The length times the width, yeah, 3 times 4. So that must be 4. So if this is 4, what can I work out now? Well, I know the whole thing here is 10, so that must be 6. So I've got 3 times 6 is 18. That's 6. So 7 6 is 42. And I think that's all I'm asked to work out, isn't it? And then this one is 4 times 7, which is 28. Now, in theory, if we add those together, we should get the area of the whole square, which is 10 times 10, 100. 18 plus 42 plus 12 plus 28, 100. Again, I'm speaking out loud here to tell you things that I would do to check. It's all right knowing the skills. It's all right knowing then some problem solving skills that will guide you through, but you also need to make sure you check. So now I am going to stop this now because I am due to have my dinner soon. I'm going to record another one a little bit later on, and that's going to be on all the algebra questions. So watch this space. So this is the first one. I'm actually putting this for general viewing. So yeah, have a look, see what you think, and let me know if you would like to go through anything else with me. I'm literally going to go through that, and then I'm going to do some OCR higher level stuff tomorrow. I have got a student who is doing higher level OCR maths, so she's got 2 more papers. This particular student I was recording this for is doing IGCSE, and it's her second paper on Wednesday, and it's her last paper. She is sitting an exam. I think it's 28 years since she last did her maths GCSE. And yeah, so this is actually a really, really keen time on the second. So yes, she's not done an exam in 28 years, and I think it's awesome. So is a big, big, big thing there, that if you are somebody who perhaps, like she was, seeing her children do maths in school and was really felt that she wanted to be able to help, but in herself she probably felt a bit can't do maths. I need to do this, you know, I can do, I'm sure. And it was through a post I put on Instagram, which basically it's not that you can't do maths, it's just not been explained in a way that you understand it. And you know, yeah, some things are hard, you know, to get a qualification in something doesn't mean that you find it easy. You can still find something hard, but you know what to do, and you've got the scaffolding around you to enable you to do that. Okay, so I'm going to call this an end on this video. This is Natalie Tarry from Natematics Tuition, and have a good evening, good morning, whenever it was you are watching this. Thank you so much. Bye bye.